Okay, welcome, welcome. This is the week 1 webinar for the online stats class. And to let you know, it's very different than the orientation webinar. All the rest of the webinars will be more like this one. And this is a webinar where we're actually talking about statistics. And hopefully you'll ask questions when you have them and, interact. So I'll be watching the chat box and checking it out. In terms of what we're doing today, I will start out with answering any questions you have that could be about the class, and I'll do my best to answer. And then we'll talk about sampling techniques, which is actually really important. It's really hard in the real world. Okay. Of course, we're going to simplify it in our class because I can't torture you with too much hard stuff, but the real world is actually really tough to make it right. But we'll get in, I'll give you examples and we'll see the different kind of sampling techniques that can happen that will make a survey better. So then we'll get into, I know this is the name of the class, statistics, but we'll talk about what are kind of the main statistics, which are the numbers that you get from the data that are important, at least for this class and for most statistics things that we do. We'll also look at charts. You've you've seen in your life charts like pie charts, and you've seen bar charts and other charts. And I'll talk about some of the charts. Not every possible chart you can do, but I'll talk about some charts, some focus charts. I'll get into the Z-score, which is a particular statistic that says something that you may never have like seen before, even thought about, but it turns out to be really important. And we'll also look at type of variables that can happen in any study. So that is the plan for this webinar. And this is our first webinar of actually doing statistics. Okay, whereas the last webinar was just talking about the class and what it takes to do well. This webinar, I'm going over statistics and the content. And in particular, the content we're going to be doing is going to come from chapters 1 and 2 from the textbook. So that is going to be the goal of today, and everything should be well. The weather's good. It did snow actually when I started skiing back home last night, but now it's not. So I don't think we'll have any power outage, which is good. That occasionally happens, but up here. So hopefully everything will be good. Let me ask, are there any questions about anything? You can put in the chat box, you can ask whatever you want, but I'll be always happy to answer any questions you have. Any questions? Okay, while you're thinking about questions, I want to remind you a few things that are important. First thing is you have assignments that are due. Just let you know, this week is very different than all the rest of the weeks because this week started on a Wednesday. So I didn't feel comfortable having the assignments due today. Instead, I moved them up to tomorrow for the initial discussion post for the statistics stuff. So just note, but don't forget that tomorrow it needs to happen. Okay. And the other thing that I want to remind you of, and I notice a lot of you have done this, and that is make sure you get partners. Okay. If you wait a while, you're not going to be able to find anyone possibly, and that'll be a nightmare for you. So make sure this week you find partners and you do that. The easiest way of doing that is through the Project One discussion board, which we talked about in the orientation. But I do want to give you that heads up on that. And if you have any questions about the project, you can post it in the project discussion board. If you have any questions about anything from chapters 1 and 2, for example, or about the class, post it in the Q&A board. Those are the main places to post. And I'll always be happy. I do check pretty often, not every moment, but I do check pretty often. So always happy to, answer questions and help you out. And also I want to remind you that we do have our embedded tutor, and we also have other tutors also, and you can go find them. And from the syllabus, you can click and you can see where you can find the tutors on the tutor part of the syllabus. So any questions? Okay. If there's no questions, I want to mention something, and this is something I mentioned yesterday too, is that the thing I love about this class is whatever we're doing, I can just go look at the news or look at what's going on, and I can find an example of whatever it is that we need to talk about. And so we're going to start out with something I found. It was very easy. I went to, if you're not from Tahoe, you may not know what this is, but it's our one of our main, I don't know if you still call it newspaper, but news, and that is the Tahoe Daily Tribune. And towards the bottom, they asked a survey question. And the survey question they had was, what kind of homelessness do you see most frequently in Tahoe? Okay. And they gave people choices. It was a multiple choice thing. And you can either people living in the street, living in vehicles, people camping in forest, people couch surfing. Okay. And what they found is 55% said couch surfing, 23% said camping in forest, 16% said living in vehicles, and 6% said living in the street. Okay. This is right from them. Okay. And then it said the Tahoe Daily Tribune, based on an online poll, sample size 350 from their website. So if you go to the website, by the way, you'll just scroll down, you'll find it immediately. And this is not some unusual thing. This happens a lot. And this is what they found. So the big question is this a representative sample? So in other words, if you look at these percents, do you think it's somewhat trustworthy, or do you think it's just ridiculous to even think that somewhere near 55% of all people in Tahoe see couch surfing most frequently for homelessness? Do you think that that is a reliable number right there, that percent? What do you think? You can pop in the chat box or whatever. Or do you think it's something you wouldn't trust at all? What do you think? Do you think it's reliable? Okay. Okay. So you're saying it's reliable. Now there are big issues. Okay. And here's the biggest issue. This is what we often call a convenience sample. All they did is they posted it. Anyone who happened to see it wanted to answer the survey question, gave it a click and let it go. The sample size of 350 actually is pretty, that is usually somewhat big enough. It's not giant, but it's big enough. If you don't know, we have somewhere around 20 something thousand people that live in Tahoe. I know that sounds like a tiny number compared to the total that live in, but what matters actually typically is how big the sample size is. And 350 is a pretty big sample size. Here's the issue. The issue is it is very possible, okay, and I don't know for sure, that the people who go online, look at this page, scroll down, and actually answer a survey like this. The question is, are those people kind of a good representation of all people who live in Tahoe? And it may not be, because maybe people who happen to be, the type of person who does that, maybe they don't go in the forest much. Okay. And maybe they don't walk on the street like I do, by the way. Uh, so they don't see the people living in the street. Or maybe they don't look at vehicles. Maybe they just have a lot of friends, that let people stay on their couch, that kind of thing. I don't know. So the point is, this is not that reliable a study, because all they did was just post it online and said, hey, anyone who wants to answer, answer. And there may be what we call bias. And bias means that these sample percentages may be very different from the population percentages because of the type of person who answers a survey question versus the type of person who typically lives in Tahoe. Does that make sense? Any questions on that idea? Okay, so this is something that you can do for just fun news that if they're wrong, no one's going to get hurt on it because nothing's going to happen because of it, right? People are just reading. So they don't have to be as careful as some others. Okay. Where there are a lot of different situations where if they're not careful, people might die. And that'd be awful. So what if instead they wanted to get a representative set of people that are in Tahoe, that are in this town? Any thoughts on how they might do that instead of just post something online and hope people will, that a representative of the city will answer the survey? Okay, and that's something that you may not know because we haven't talked about it yet. And that's what we're going to do. So, what we're going to spend is kind of the first chapter is really mostly about how do you get a representative survey, a representative sample, so that you don't have that bad bias. It's almost impossible to get no bias, but you can reduce the bias in different ways. That makes sense? Okay, so here are here is an example of another survey. I went online today, literally copy and pasted it. And this was a Gallup poll survey. And what they asked is, do you approve of the job Trump has done so far? And of the people that answered the survey, 36% said, yes, I approve of what Trump has done for America. Okay. And the other 64% did not approve of the job that Trump has done. So now let's read how they actually found the people to survey. They did not just post it up on some online page and hope people would answer. Here's what they did. First thing, they had 1,321. Okay. And what they said is it was a random sample. And I'm going to mention it's they lied about this a little bit. um, They said they had a random sample of 1,321 adults age 18 or older. Okay, I want to make a big comment right now about this class in terms of your projects. You are not allowed to survey children. Okay, any guess on why I'm not letting you survey children? Any guess? It's not because I hate children, by the way. I'm very, very fond of helping out children. I'm actually on the Boys and Girls Club, so board. Any thought on why I'm telling you you're not allowed to survey children? No one's saying? Okay. Yeah, yeah. It's against the law, basically, without all kinds of legal documentation with signatures from parents and lawyers and all kinds of other things. Don't even think about surveying children. Got it? Do not go to some elementary school and do a survey, okay, or even a high school. Okay, you can survey college students, that's okay, but not like little children because there's all kinds of legal issues and this is publicly heard. I'm posting on this YouTube, so if someone tries to sue me, then I can actually show them this video and say, nope, you can't sue me because I told everyone they're not allowed, even if you do it, but you should not do it. Got it? Yeah, and that consent form, you need a lawyer just to like come up with a consent form. Good luck. So don't do that. Okay. So they did adults. Okay. Living in all United States and Washington, D.C. Okay. And they also said each sample of national adults includes a minimum quota of 50% cell phone respondents, 20% landline, with additional minimum quotas by time. Okay. Now, having quotas, I'm going to go for the by time. That's probably the most makes sense. That helps stratify by when people are available to get a survey. Because people who are available, say on a Tuesday at 2 p.m., there might be a different kind of person if they're available to answer a survey question because they're probably not working. And then all of a sudden they're a different kind of person and they might be, I don't know, more likely to like Trump or vice versa. But the point is that they tried to make sure that you had minimum quotas by time. Does that make sense? So they said they did a random sample. I'm going to tell you the truth in terms of what they really did. It wasn't a perfectly random sample because that's not possible. It is not possible to do a perfect random sample of all people in America because have you, and let me ask, pop in the chat box, have you ever had somebody ask you to do a survey and then you didn't do it? So yes, if you've said, I won't do it once in your lifetime, or no, because you've always answered the survey when someone asks. Okay, so you'll notice that a lot of you are saying yes. We actually have one person who said no. Okay, a couple people that said no. So people who will always do a survey, they might be a different type of person. Maybe more of a Trump lover or less than a Trump lover, but they might be a different kind of person, those who tend not to do surveys. And then you have bias. Okay. And what actually Gallup did, if you know the details, is they randomly picked phone numbers and then they called those phone numbers. But I'll tell you, if someone calls me and it's a number I don't recognize, I don't even answer it. So I'm one of those no's. I don't answer the survey because I don't even answer the phone if it's a number I don't know because I think it's some spam. So there's bias. It's not truly random because there's people who won't answer. Does that make sense? Okay. So the only way to make something fully random is to make sure that there is no what we call voluntary response bias. Voluntary response bias means that people do not voluntarily respond, and then you have bias. Does that make sense? Okay, it's very hard to do with people. You can do studies where you can get randomness, and that might be like, let's say you want to look at the temperature in, random areas in the United States. Well, it's not that hard to, get a map of the United States, get a grid, and then pop, because you only have so much time, you maybe pop, 40 different little, 1 acre points, then go to the weather forecast, find out what the temperature is in those 40 places. And that's a perfectly random sample. Do you see? Because you can have a computer randomly select those, and there's no voluntary response bias because, an acre of land isn't going to say no because they're not people. Does that make sense? So there are ways of doing pure randomness, but almost never with people. Any questions on that? Okay. Um, Also, they said an additional sampling error, question wording and practical difficulties in conducting surveys can introduce error or bias in the findings of public opinion polls. Okay, so that might be, you ask the question, but maybe the person doesn't speak English. Then there's going to be bias there too. Does that make sense? And that's like a question wording. They don't understand the words. Okay, all kinds of different things could happen. Any questions on kind of bias and the big issues? Okay, let me talk about one of the main ways that you can reduce bias when you're doing a survey, especially with people, but also with other things too. And that is called stratified sampling. I think it's probably the most common scientific way of doing a survey and reducing bias. And stratified sampling really has a step-by-step concept, which I'll show you the steps in a little bit. But here's what you do. You determine the strata, such as age, gender, income, etc. So what you do is you say, okay, where might the bias be? So for me, if I were to do one about Trump, I would probably stratify by political affiliation. Because my guess, I might be wrong, but my guess is that Republicans are probably much more likely to think that Trump is doing a good job than Democrats. Okay? Yeah, I'm sure my guess is you would agree with me on that. So what you would want to do is you would say, all right, I'm going to let political affiliation be a strata. Do you see how that works? Okay, age might be a good one too, because young people might be more likely to hate Trump than older people. Does that make sense? Okay, so you could stratify by age. So there's different things you can stratify by. In our class, we're going to kind of stick to one thing to stratify by when you have to do a survey. But in the real world, you pick a bunch. Okay, so step one is you determine the strata. Step two, okay, which I didn't write here, but oh yeah, step two is, yeah, I did right. You research the percent of each group from the population. You can usually do that one online pretty easily. So if you wanted to find out the percentage of Republicans in America, I would just ask, Gemini or whatever, and what percentage of Americans are Republican? And then it'll tell me. So that's an easy one to research. Some things are harder to research, some are easier, but some examples are easy. So the next thing you do is you research the percent of each group. So in this case, it would be like the Republicans, the Democrats, and maybe the others. Okay, the next step is you multiply the percentage by the sample size. So if you want a sample size of, say, 500, and let's say 40% of Americans were Republican. By the way, I don't know what percent actually are Republicans, but then you would take 40% of 500, and that would be 200. And that would be the quota for the Republicans. And then you'd find the quota for the Democrats and the quota for the others. And then you conduct the survey, making sure that each quota is exactly established. Okay? So if you've surveyed 200 Republicans already, the next person you ask turns out to be a Republican, you don't even ask the question. Okay? If you've only surveyed 180 Republicans, you got to make sure you get 20 more. Does that make sense? Any questions on how stratified sampling works? Okay, that is again one of the main types of sampling techniques. I'll I'll explain some others in a bit too, but I want to start on that one because that's a big one. It's the most commonly used one for Project One, by the way. Next week I'll talk about that. Okay. Then there's two main types of variables. Okay. So the idea here is you ask the survey question, and then the person that you asked answers it. And for us, there's going to be two main types. One is going to be their answers are word answers, and the answers are number answers. So, for example, in this one, which kind of homelessness do you see most frequently in Tahoe? There were four choices, and all four choices are words. Do you see how that works? So that's called qualitative. Qualitative means you have a word answer. There's one very special type of qualitative that we're going to be doing in this class a lot, and that is when there are only two choices, and that's yes or no. So we're going to have the yes no qualitative, and that we'll get into that later, not today. Okay, and then there's quantitative. Quantitative are number answers. That would be like, how old are you? If I ask you how old are you, you're not going to say, ah, I'm very old. No, I hope not. You're going to say, I'm, 42 or I'm 18. You're going to give a number. Does that make sense? So if the answer to the survey question is a number, then it's called a quantitative variable. Any questions on that? Any questions? Very important. If you can't get this down, basically you won't pass this class. So always think about what is the survey question, what's going to be answered from the survey question, and will it be a number or a word? Okay. And sometimes when I say survey question, it could be does the data you're collecting. So if you're looking at the temperature, that example I gave, the temperature, in different places in America, then that would be quantitative. It's not a survey question, but you look at that place, you say, okay, what was that temperature? And you go and you look it up and you find it, and it'll be a number. And it might be, hey, the temperature is, 68 degrees Fahrenheit. Do you see how that works? Okay, we're going to be using this letter for the rest of the entire course, and that is N. N is the letter we're going to use, and it's lowercase n, by the way, for the sample size. Okay, so the sample size of that first survey we looked at was 350, so N was 350. Okay, so I'm going to be using, and we're going to be using an N a lot. Okay, and you can think of it as N stands for the number of people you asked, or the number of data values you got. Okay, so that's N. Any questions on that? Okay, then another again. These chapters, by the way, there's not that much math in it, but there's a lot of words. So you'll notice we're doing words. So then there's statistics versus parameter. So here's the definition. A statistic comes from the sample, and a parameter comes from the population census. So for example, if you asked, if you wanted to find out, what's the average age of college students, and you did a survey of 200 college students asking them how old they are, then the average of the 200 people you asked would be a statistic because you only asked 200 and there's millions of college students. Okay. The parameter would be the average age of all college students, okay, in the entire population. And that could be the United States if you're thinking about that. The parameter typically you can't get. You typically use the statistic to make a best guess for the parameter. Any questions on that? Have I lost anyone? A lot of language. Okay, and there's lots of different types of statistics that we're going to be looking at, and I'll show you that in a little bit. Okay, one is the average, which in our class, we're not going to use the word average, we're going to use the word mean. Not because I'm being mean, by the way. It's just the word they use in statistics for average. Okay, is mean. Okay, so here's sampling techniques. Random sampling. Okay, so random sampling is almost impossible in most cases, but it's what you hope for, but you can't get it exactly, so you get a kind of it. Um, so typically what you do is you have to order the entire population. Then you use a computer to pick n random numbers from 1 to the population size n. Then you survey the selected individuals and make sure that every single individual that you surveyed must answer the survey. Otherwise, it's not random anymore. Okay, so big issues. Do you think you can order the entire population of America, for example, of people? Do you think you can get a list of every person in America? Yeah, no, it's not possible. Not going to happen. Okay? It is not possible to do a random sample of all Americans. That's why that Gallup poll was, was wrong. Okay? They did random dialing, but that's not the same thing because people say no. Okay? You can't do it. And some people don't have phones, and then you've lost them. Does that make sense? Okay? So random sampling is almost impossible whenever you have a large population of people. If I could do, say, a random sample of students in this class because I could get the list, and you could too, actually, because you have the ability through Canvas to get a list of every person in the class, all 30 of you. And then, because I'm the instructor, you probably would all answer my survey question because you would feel uncomfortable if you didn't. And so I would maybe pick, let's say my sample size was 10. I would get my computer and say, hey, pick 10 numbers from 1 to 30. And then I'm going to, in the order of the people on the list, I'm going to grab those 10 and I'm going to make you answer the survey. Do you see how that works? So I could do that. Okay. You could also randomly pick locations because again, there's no voluntary response bias as long as there aren't too many locations. If there's millions of locations, good luck. But if there's 100 or 200 or something, that's not a problem. Any questions on that? Okay. Then there is stratified sampling, and that's what we mentioned. It's so important. I'm going to restate it. In step one, decide on the strata. Step two, research the percentage of each type. Step three, multiply the percents by the sample size to establish quotas. Step four, conduct the survey ensuring the given quotas. Okay. Note those steps. Either write them down in notes or make sure that, go back and you can look at this online and, on YouTube and you can see it again if you forgot. But these steps are essential and that's what the steps are. They have to be done. Okay. Now there's other kinds of sampling that are really important. Okay. Here's a problem with, say, stratified sampling. Sometimes, especially like if you're asking people in America, You don't want to just ask all people in Los Angeles, for example, because those people might be very different. For example, the Trump, do you like Trump thing? Um, they might be very different than the rest of the country. So it could get really hard to, if you just picked like, a person from every state, you'd have to go to all 50 states. That would be so much work. Does that make sense? So instead, what you typically do is you do what's called cluster sampling. And this is what you do. You divide the population into clusters. Okay? The clusters that represent the population. And those clusters should not be that large, by the way, because you're going to have to sample every item in some representative chosen clusters. So if your clusters have 1 million people in them, it can't happen. You're not going to be able to survey 1 million people. Does that make sense? So clusters might be, say, I don't know, street blocks, because there aren't that many. You might be able to survey everyone on the block. Okay, let me give you an example of the Forest Service. And by the way, one of the things I have done in using stats is I was hired by the Forest Service to do some statistical assistance for them. And one thing that helps is use cluster sampling. If let's say you wanted to find the average height of pine trees in all of the Sierra Nevada mountain range. Okay. There's like billions of pine trees in the Sierra Nevadas. You can't get them all. You cannot get a parameter because there's too many. Does that make sense? So you can get a statistic, but you want to see, can you get a representative sample? Okay. And it's a lot of work to get to different places in the Sierra Nevadas. I love hiking and I love going to Sierra Nevadas, but it could take days and days to get to some of the places because there's not even any roads to them. So what you do is you pick clusters. And one way you can do it is maybe you can say, all right, the clusters will be acres. And you can pick representative acres in the Sierra Nevadas. And you might want to say, okay, we're going to make it representative by you're going to pick kind of a good proportionate number of acres that are high elevation versus kind of middle versus lower in the mountains. Maybe by water, not by water if you're doing height of pine trees, that type of thing. And then northern facing and southern facing, that turns out to be really important for pine trees. So you're going to get a representative sample of acres in the Sierra Nevadas. Then let's say you pick 10 representative acres. Then you're going to go to those 10 representative acres. And then you may have to hike a long way, but hey, you can get to those 10. And then you're going to measure the height of every pine tree in each of those 10 acres. And that'll give you a pretty good representative sample. Any questions on that idea? Okay. Let me tell you the kind of most common cluster sampling of college students. What do you think the most common clusters are? This is something you should all know because you're college students. What's the most common clusters for college students? If you don't know, I'll tell you, you'll say, oh, of course, I should have thought about that. What do you think? Remember, it can't be, 20,000 people because that would be too hard to answer everyone. What's a what's the most common cluster for college students? Okay, what year you're in? No, that would be too hard because if you said freshman, there's over 1 million freshmen college students. Do you see that? And then you can't survey every freshman in all of America, for example. Does that make sense? Major also, there's hundreds of thousands of business majors. So that won't work either. All right. These clusters are too huge. All right, maybe I'll tell you and you'll say, of course. Classes. Okay, for example, the stats class you're in right now. There's 30 of you. Yeah, there we go. Someone said classes. Um, yeah, so classes. So what you would do is you'd pick representative classes. So you might pick, maybe a couple math classes, and when I say classes, I don't mean every calculus class in all of America. I mean one particular section. You might pick a couple of math classes, maybe some art classes, maybe a history class. So representative kind of classes. and maybe even by time too, a morning class and a night class, maybe some online classes. Um, and then you would go in and you would survey. You would walk into the classroom, or you would, get all the online students in that class to answer the survey question. And that'd be a lot easier, wouldn't it? And that's done a lot for college students. And that's the most common cluster sampling for college students. Okay, then there is systematic sampling. Okay, let me give you the definition and I'll tell you how it's used a lot. It's sampling every nth item in the population. Okay, so let me give you another example that I actually did. It was a former student who asked me if I can help him. He had after he graduated from college, he got a business and he manufactured towels, and he wanted to show that his towels were better than ones made in China. So he wanted a representative sample of the towels that he was manufacturing. So what I did is I said, all right, why don't you grab, and then what he had to do is he wanted to see how long they would last, as in how many times can you put them in the washer before they started dying. So what I did is I had him grab every 500th or so, I think it was 500th towel that came out of the assembly line at his manufacturing plant. And then I had him throw those towels in that from the sample, every 500th towel into the washer a bunch of times and see how long they lasted. So that was every nth item. The other place it happens is for people, for example, it could happen, say, in the supermarket. They could say every 100th person who walks into the supermarket, we're going to survey or we're going to see how much money they spent. Does that make sense? And that'd be every nth item. Any questions on systematic sampling? So that only works when you can order them and you can kind of list them all somehow. Convenience sampling I already talked about. That's collect data on whatever's easy. The problem with that has horrible, horrible bias. So you only do that when you really don't care whether you're right or not. So you just do that when you're doing a fun survey. Okay. Then there's the randomized control sample. Okay. And that is you get many people, you put their names in a computer, have the computer randomly select, say, half of them, okay, for them to be the treatment group. And the other half is the control group. Okay. In the last 10 years of all studies that were ever done, what I consider, you may not, but what I consider the most important study in the entire world that was ever done in the last 10 years used randomized control study. Any guess on what I'm thinking was the most important study that was done in the last 10 years? Okay. You might be able to guess this. If not, when I say it, you'll say, oh, of course. Okay. Or maybe you don't agree with me. Any thoughts? What the most important study you think might be it used randomized control? Allergy testing, that's pretty important. You're kind of close, but not quite. Not allergy. That they've been doing for not just 10 years. Okay, so let me tell you, to find out if the COVID vaccine worked, don't you agree that was pretty darn important? Okay. And I'll tell you, before I got my COVID shot, okay, my vaccination, I read to find out how did they do the study, because if they had some very biased study that was meaningless, I wasn't going to get my shot. Okay. Someone was going to say COVID. So here's what they did. Okay. And I read the details. They grabbed many people. Any guess on how many people they got to volunteer? Not millions, not 15. Okay. Kind of in between. Not 1,000, 40,000. They got 40,000 people. I don't know whether they did 20,000 in the treatment group and 20,000 in the control group. I didn't know exactly how many in each, and that wasn't that important anyway. But they had a nice big sample size. Millions would be too hard. It would have taken, might have taken 50 years to get that many people to volunteer. So they got 40,000 people. And then of those 40,000 people, let's say they did 50-50. 20,000 of the people got the COVID shot. The other 20,000 people got a shot and were told they got the COVID shot. They thought they got the COVID shot. And then over the next couple months, they watched those 10,000 people who got the real one and 20, what they call a treatment group, and the 10,000 that were in the control groups, and they call that the placebo. And they looked to see the percentage of people in the treatment group that ended up getting COVID in those next couple months versus the percentage of the people in the placebo or the control group that got COVID. Does that make sense? And what they found out is that the percentage of people who got COVID that were in the treatment group was much smaller than the percentage in the placebo or the control group. And because of that, the government, not just the United States government, but governments around the world said, we're gonna accept this as a way to help prevent COVID, and we're going to encourage it among the world. Okay. Don't you agree that's a pretty darn important thing that happened? And if you didn't do the statistics right, a disaster could have happened. Any questions on the randomized control study? It's really used a lot in medicine. I've actually been one of the, I was in one of these, not for COVID. It was actually when I was in college many years ago. And um, I saw in the newspaper in those days before internet, it said if you have the runs, run to the hospital, and we're gonna put you in this test, and we're gonna give you money for it. And I did that, and it turned out I was in the control group, and I didn't get better. A day later, they apologized, and then they gave me real medicine. It sucked. But I've actually been on the other side and been in the placebo group when I was a college student. Okay, I didn't die, but it just sucked for a day. Okay. Any questions on these main types of surveying? And these are the main types people use. Okay. There are some others, but not in elementary stats. Any questions? Okay. So here's something I have a question for you. What quantitative information are you interested in about each other? First person who puts something in the chat box, we're going to ask. Okay, age. We'll go for that. Okay, so here's a survey. The answer is, how old are you? Sounds good. And here's what you have to do. You have to put something in the chat box. If for some reason, again, this is not going to be public, but if for some reason you don't want to be public about, I mean, if you don't want your classmates to know how old you are, just put something reasonable. Don't say you're 1,000 years old. That's obviously not right. And you're not 1 year old either. But best is if you say your real age, if you don't mind people knowing. Okay, and pop in the chat box because I want some data. I want real data. Good, good. I see it coming in. What we're going to do is we're going to go to the calculator. We're going to go to the one variable statistics calculator, which actually kind of showed yesterday, but now we're really going to get into it because this is a biggie for today. Okay. And what it says is type in the values from the data set separated by commas. For example, 2 comma, 4 comma, etc. And then hit calculate. I try to make this simple. All right, so now I'm going to put the data in. And 30, 25. 27, 23, 38. 37, 23, 39. 28. Okay. So then this is a sample, by the way. This is a sample of, maybe all students, that take statistics or something like that. So I'm going to go sample standard deviation. And then I click calculate. Oh, it didn't like minimum. I'll have to go find out what's wrong with the code there. It should know minimum. Sorry about that. I could look and find the minimum. That was 23. Maybe because there's two of them. Sorry about that. I'll go and fix that in the next few days. I coded this all, by the way. So the mean, we've kind of talked about that. That's the average. But we're going to, in this class, you need to use the word mean. Okay, the mean is 27. So that means if you take all of the data values, add them up and divide by the total, that's 27-year-old. Any questions on the mean? Okay, the minimum doesn't say here, eventually it'll say is 23. That means the youngest person that in the sample was 23 years old. Okay, Q1. Okay, so Q1 is basically says that Q stands for quartile. This is very important. This is the first quartile. That basically says that if you if you look at the people that are 23 years old and younger, that represents about 25%. Because a quarter is 25%. Any questions on that? Now this is complicated and drives me crazy, but it turns out the Statistics Society of America has not agreed on a formula for Q1. I hate that. I actually emailed them asking, please, and they said, no, we can't. There's too much anger, so they couldn't do it. But so right now you don't have to know the formula, but just the idea, around 25% are at or below 23 years old. The median, I bet you've heard the median. You probably get that in like sixth grade or something. What's the median? Do you remember what the definition is? The kind of the idea of the definition, at least? Yeah, it's kind of the middle. It turns out that if you list all the ages in order, and if there's an odd number in the sample size, then it's the middle. If there's an even number, it turns out there's two middles. You take the average of the two middles. So that's why you'll see 27.5, because it turns out there's one, two, three. Oh, you know what the problem is, I think? I think I put a comma there. Let me try again. There we go. That was a problem. I screwed up. Yeah, don't put a comma at the end. There's a problem. First quartile is 24. That comma messed everything up. Okay, so the first quartile is 24. So 24% or below are around 25% are around 24 years old or below. The median is again that middle of the ordered list. Q3 is called the third quartile. And that basically, there's two ways of thinking of it. One is there's about 25% below that number. I'm sorry, 75% below or 25% above. Means the same thing, kind of. But again, the formula is too complicated and not even too complicated. It's not agreed upon. So just trust the calculator and use the calculator. Okay, the maximum is 39. That was the oldest person, was 39 years old. Any questions on that? These, by the way, are all statistics because these are numbers that come from the sample. Then comes the biggest one, kind of the most important one that you may not know that much about in this entire class. Okay, median is really important, but you know average anyway, and that is standard deviation. And I'm going to give you the idea of a standard deviation because that's the most important thing. And the idea of the standard deviation is if you think about this kind of list of ages, and we had the mean was 30 years old, then you kind of say, kind of on average, how far are the ages from 30 years old? And the standard deviation is around 6.4. So that means kind of on average, the ages are around 6 and then 6.4 or so years away from 30 years old. Does that make sense? Okay, it's not exactly average, but the math is a little too complicated for me to get into. Okay, but I want you to get the idea of that. It's a really important thing. If the standard deviation is big, that means the ages are all over the place, possibly. If the standard deviation is really small, that means the ages are all right close to each other. Here, 6 years, not tiny, not big. Any questions on that? It turns out that um, if you have a kind of a normal curve, kind of a bell-shaped curve, then about 68% will be within the standard deviation of the mean. So if you subtract 6.4 from 30, you get 25.6. If you add 6.4 to 30, you get if you subtract 6.4 from 30, you get 23.6. If you add 6.4 to 30, you get about 36.4. So about 68% are between those two ages. Okay? If you have a bell curve, okay, which we're going to call a normal curve, and we'll get into that. We have a whole chapter on that. Okay. All right. One thing you're always guaranteed that yeah, if you go two standard deviations out, that you'll never have fewer than 75% in between. Okay. If you have what's called an outlier, so like if let's say there was a 78-year-old person in the class, that'd be really a big outlier. The standard deviation is going to go way up. Got it? Okay. I want to let you know for our class, we're not going to even get into the variance. Okay. That's really used for the calculation of standard deviation. I'm not going to go there. Okay. Then comes the IQR. IQR stands for interquartile range. And what that is you take Q3 minus Q1. And that gives you the range of the ages, how wide the range is for the middle 50%. Okay, it's kind of the middle half of the group is spread out by 13.5. Any questions on what IQR is? Okay, sample size is 9. That means n equals 9. There were 9 people that answered. Okay, you want me to repeat IQR? So IQR is the third quartile minus the first quartile. Now, the third quartile is the top 75%. The first quartile is that lower 25%. Okay, so if you look at the range from the lower 25% to the top 75%, then that range will be IQR. Does that make sense? Do you see how that goes? And that is a spread of 13.5 years old in this case. That make sense? Okay, good. It's very important, by the way. This is going to be a big part of what we're doing, and you're going to have to get into that in the project, and you'll be asked questions on it and all kinds of stuff. Okay, so then there is the histogram. You've all probably seen a histogram before. Okay, so this is a histogram. By the way, histograms can only be used when you have quantitative data and the width of the bars all have to be equal to each other. Okay, and that is the histogram. So what this histogram shows, the way it's written here, is that there are 3 of you that are between 23 years old and 25.7 years old. There are 2 of you between 25.7 and 28.3 years old. Does that make sense? Do you see how to read the histogram? Okay. This histogram is bimodal. So bi, that is a prefix. What does that mean? You've heard other words with the first 2 letters bi. Yeah, 2, right? If you have a bicycle, there's 2 wheels. I'm sure you all know that, right? Okay, if you had a tricycle, how many wheels are there? Yeah, 3. So that would be 3 if it were trimodal. Okay. If you had a unicycle, how many wheels are there? Yeah, 1. I'm trying to give you something that you might be more familiar with. Okay. Okay. So there'd be 1 meal. So if you had one kind of highest bar, we would say it's unimodal. If you have 2, it's bimodal. Sometimes over 2, you just say multimodal because it gets too hard to remember all the numbers after 2. So in our class, unimodal, bimodal, and past that will be multimodal. Any questions on that? Okay. This is not a normal curve shape because a normal curve shape looks like a bell. Kind of on the left and right, it's low, and in the middle, it's high. Okay. And we don't have that. We actually have here left and right, it's high, and the middle is low. Do you see that? So this one's definitely a bimodal distribution. It's not uniform. So you can't use that 68% because you can only use that when you have a somewhat uniform distribution. Okay. I mean, sorry, not uniform, not normal. It's not normal. Uniform is flat. You've all heard the word uniform when it comes to the military. Why does everyone wear a uniform in the military? Okay. And same thing, like say in some private school, they'll wear uniforms. Why do they wear a uniform? There's a reason. I don't know if you ever even thought about it. Yeah, to unify, not to discriminate, so that everyone's kind of treated, everyone looks basically the same. So if it's a uniform distribution, that means all the bars are the same. Any questions on that? It's just flat on the top, and that would be uniform. Okay, and this one's definitely not uniform. Okay, then the other thing that could happen, which isn't this case, is it could be skewed left. And skewed left means that it's unimodal, but the the left-hand side is the low part, and the right-hand side is the high bar. Skewed right means the left-hand side is the high part, and the right-hand side is the skewed right, and the right-hand side, the skewed right means the left-hand side is the high bar, and the right-hand side is the low stuff. So those are the different things, and it's all in the book too, so you'll hear it, but you're hearing it now. Take notes because these are all important words. Okay, and it is important that you know how to look at a histogram and see if it's skewed left or skewed right, or uniform, or unimodal, or bimodal, or normal, symmetric. Okay, so skewed left means the left-hand side is low and the high side is on the right-hand side. Skewed right means the left-hand side is high and the low is on the right. So the word is the low part. Skewed right, low, right. Skewed left, low, left. Does that make sense? Any questions on that? Lot of vocabulary. Okay, let me get to the next important chart. This is used a lot, but unlike histograms almost everyone can read a histogram and know what it means. The next one, most people don't know what it means. Okay. So by the way, histogram is great at seeing the distribution. The distribution means the shape of what's going on. Skewed left, skewed right, normal, all that kind of stuff. Um, you can't see any individual data values. You can only see ranges though with the histogram. So pros and cons are important. For this guy, this next chart we're looking at, this is sometimes they'll call it a box plot. Sometimes they'll call it a box and whiskers plot because you can kind of see two little whiskers out here. All depends on what you want to give the short name or the longer name. And this gives what's called the five value summary. So what we have is we have the left bar here is the minimum. And the minimum age was 23 years old. We have this left-hand side of this big blue box is the first quartile, Q1, and that was 24. Then we're going to have this line here that's somewhere within the box, and that'll be the median, and that's 28. Typically, they do not write MED and Q1 and min and Q3 and max. I did that on my calculator so that you could remember what all these things are. But when you see this in the real world, you'll almost never see these hints. Just let you know that. So the median was 28. Q3 was 37.5, and that is the right-hand side of the bar. And then the max, that's the right whisker, and that's 39. So they'll call this, again, sometimes called the 5-point summary because it has 5 numbers. Notice that the bar itself is the middle 50% because Q1 means 25% below, Q3 means 25% below, above it. So between Q1 and Q3 is the middle 50%. So it's bar charts are really good if you care about that middle 50%. And that is kind of, oh, what's typical? That's the middle 50%. Any questions on that idea? Okay. The kind of the cons, the bad thing about the bar, about this box plot, the box whiskers plot or the box plot, the cons of the box plot is one is a lot of people don't know how to read it. And so if you're going to present this in front of an audience and the audience is not that educated, they'll have no idea what this says. So that's awful. Another is it's really hard to see the shape of the distribution here. Whereas with the histogram, it was very clear this is bimodal, right? You cannot look at this box plot and see that you have a bimodal distribution. Okay, do you agree? You can't see that. So there's different things you can and cannot see from each of these. Okay. Now comes the next one, and that's going to be the stem and leaf plot. Okay. So again, in neither of these can you see any individual data values. Okay. You cannot see from either of these whether there was anybody who was, say, 30 years old just by looking at this. You know that there's one person, exactly one that was between 28.3 and 31. So they could have been 29, 30, or 31. You don't know exactly how old that person was by looking at this histogram. And similarly, you have no idea whether there was anyone that was 30 years old from this box plot. Do you agree? On the other hand, with the stem and leaf, what that does is it takes all the data values and it collects them in a picture, but without losing the numbers. The stems in this case are the tens, and the leaves are the ones. So, for example, this number 5 right here means 25 because the stem is 2 and the 5 is, so 2 times 10 plus 5 times 1, 25. Okay. How about this number 7? How old is this number 7 person? Yeah, that'd be 37 because the stem was 3, the leaf was 7. Okay. So this actually, you actually get all the data values back. Any thoughts on what the cons are, what the bad things are with the stem and leaf? There's definitely some not so good things. There's 2 main cons. Any thoughts? Yeah, one is most people have no idea how to read this. Okay, and by the way, people who hate numbers are going to like look at this and get scared. We call those number phobes. And there's another biggie also, and that doesn't apply to this example. But let's say you looked at how about the temperatures? Look at the look at the temperatures of all the states of all 365 days of 2025. You would have a huge number of numbers, right? Be thousands and thousands of numbers, and you wouldn't even be able to fit the numbers on the paper or on the screen. So if you have a giant, huge data set, you can't do a stem and leaf diagram. Does that make sense? Because it'd be just too many numbers to put in. Whereas you can do a histogram because you just make sure that this y-axis, is set so that, up this high might be 1,000. Do you see? And box plot, no problem with a large data set. Any questions on these three types of graphs? These are the three we're going to focus on in our class, especially for project one, by the way. Any questions? Okay. And by the way, I created these pretty recently um, because I thought that would be a nice thing to have. Are there other kind of charts besides these? Are these the only kind of charts that you've ever seen in your life? These three? What do you think? Okay, yeah, there's a pie chart. So let me tell you, it's a really funny story. This happened in July. I actually had a professor say, "Can you put in your calculator that we use? Can you put in a pie chart and a bar chart? So that deals with qualitative data. Can you put that in your calculator?" So here's what I did. So let me go to the calculator, and we can go to the bar and pie chart calculator. And I'm just going to make something up. Let's say we had, how about freshman? I'll try fresh. And let's say we had for 58, nine of them. Okay, then comma, and then sophomore. We had 72 of them, comma, and then we had freshmen, sophomore, juniors. I'll go like June. And let's say we had 80 of them. And then let's suppose we had our seniors. And let's suppose we had 41 of them. Okay, I'm just making up these numbers. And then we hit generate charts. And that's going to give you, it's going to give you a bar chart. Okay. And here we go. Somebody wanted me to be able to hide these height numbers. I don't want to do that, but so I'm not doing, so I'm, the standard is show heights. And it gives you the bar chart. This tells you how many in each. Notice this works for qualitative data. That's fine. And it says fresh, soft, June, and senior. And then a pie chart. Okay. And you can also show and hide. And there's a pie chart. Now, all the rest of the calculator I had already coded. It's a lot of work to code all this stuff, by the way. But I tried something new, something I had never done before. I asked ChatGPT, can you make, can you write a JavaScript code to make a bar chart and a pie chart? And I did I did some extra prompts and ChatGPT made this beautiful thing. Isn't that cool? We're in a new world. So all the rest of it I coded myself. This one I let ChatGPT do for me. Any questions on the pie and bar chart? Kind of fun? Okay, let me go back to the stuff. We've kind of talked about all this stuff already. Okay, so we've got all this. We've talked about our quartile standard deviations. Next one I want to talk about is a z-score. The z-score, it turns out to be really important, and here's what it is. The formula is z equals x minus, anyone know how to read this symbol right here? It's a Greek letter. If you read enough, you'll see it. Okay. And by the way, I love cats. Mew, mew, mew. Okay. That's how you read this symbol. It's mu. Okay. And it's a Greek symbol, and that's what it is. Divided by sigma. So mu is the mean. Sigma is a standard deviation. Those are the symbols we're going to be using for that. And this is the sigma symbol, which doesn't sound like a cat, sorry. Okay. And x minus mu over sigma gives the idea of how unusual a value is. So let me give you some examples. Okay, we've already talked about all the other things. So here's the idea. Okay. So let me do one more thing about one more example that I like to do. Suppose my goal is to have most of the students pass. Okay, I want most of you to pass. Okay, I really do, by the way. It is a goal. Okay. And passing, hopefully, is 70% or higher for the score, because that's in the syllabus. If the average score is 74%, am I satisfied? Am I happy? What do you think? My goal is to have most of the students pass, and the average score was 74%. Am I happy? Okay, and this was a trick question. For all of you who answered no, you're wrong. For all of you who answered yes, you're wrong. The answer to this is I don't know. This is not enough information to know whether I'm happy or satisfied if my goal is to have most of the students pass. Because it's possible that just about all of you got a 69%, but one person got 100%. And that's going to push the average up to around 74%. Does that make sense? It's also possible that all of you got 73%. And that means all of you passed. So it could go either way. It's not enough to just know the average or the mean. On the other hand, if the standard deviation was 0.02% and the mean was 74%, now am I satisfied? What do you think? Yeah, so the answer now is yes, because that means just about everyone got exactly 74%. Within the average distance from 74% was 0.02%. So just about everyone passed the class. You all got C's. You may not be happy, but I'm happy you all passed. That's what I want. Do you see that? Okay. So without knowing the standard deviation, it's really hard to really understand what the data is doing. You need to know the mean and the standard deviation. And I've mentioned this already. If you have a bell-shaped curve, normal curve, then you have a 68% chance of being within one standard deviation of the mean. Okay. Turns out there's a 95% chance of being within two standard deviations, and there's a 99.7% chance, so almost you're like so convinced it's going to happen of being within three. If you're more than two standard deviations in our class, this is a definition. Note this because there's a few definitions of this word, but we're using this one. If it's more than two standard deviations away, it's called an outlier. That's the definition of outlier for this class. If you're more than three standard deviations, it's called an extreme outlier because it's very unlikely or very unusual to happen. Does that make sense? Any questions on that? Okay. Just a note, just a reminder on the charts, we already saw this, but histogram's great for showing the shape of the distribution. Stem and leaf is the stem is for higher digits, the leaves are for the next digit. By the way, if all the answers were all the same within 10 of each other, then it tells you nothing. Stem and leaf don't isn't good, or if everything was a one-digit number, don't use stem and leaf. Okay. So also if the audience doesn't know, then doesn't know statistics is terrible. If there's a big collection of data values, it's also terrible. So there's kind of three main reasons. Okay, box plot, again, it shows the 5-point summary. We've talked about that. It doesn't show the shape of the distribution well. There are others, I'm not going to get into all of them. I showed you the pi and bar. Okay, so now let's go more into the z-score. Z is x minus mu over sigma, because it's 7:15 now, and I try to end around 7:30, by the way. So usually within 15 minutes of some time. Okay, so this guy is mu. Mu. This one is sigma. Okay. By the way, the day before class in the spring quarter, I was in tears. Do you know why? Mew. My cat died. It was so sad. I was almost crying during my webinar. Okay. So if z is greater than 2, we call it an outlier. If z is greater than 3, it's an extreme outlier. So the z tells you how many standard deviations from the mean you are. Okay. And I put absolute values because if you're on the left, then it's negative. If you're on the right, it's positive. So absolute value makes it outlier, then you can look at outliers. All right. So let me give you an example. Okay. Do we have anyone that is in or wants to be in the medical profession here? Okay, good, good. We have a few. At least one. Okay, so this is really important. Okay. Medical profession uses a lot of statistics. So here's an example. Okay, suppose that you're in a hospital. Okay. And you're taking care of an infant that was just born. Okay. By the way, my brother, that was his job. Okay. He's an OBGYN and his job was delivering babies. So I know that's the stuff from my brother. Okay, suppose you're in the hospital and you're taking care of an infant that was just born. And the z-score in the weight of the baby is negative 3.7. Okay, what will happen to that child? Any thoughts? Especially those who are interested in being into the medical profession, because this is the whole point of statistics for you, is to understand what to do when you see the stats. If the z-score of that child was negative 3.7, what's going to happen? If you say you were the OBGYN or whatever. Any thoughts? Yeah, it might pass away. There's a very good chance it's going to pass away because negative 3.7 is an extreme outlier. Negative means on the low side. So it's a really, really tiny baby. Doesn't mean it's dead, just let you know. But what it means is you are going to put that baby into intensive care. And that baby is going to need all kinds of medical treatment to keep that baby alive. Does that make sense? Okay, it might not die. Okay, I'm not I'm not as negative as some other people are. You have a chance of living, but you worry a lot. Does that make sense? If the z-score was negative 3.7. Okay. Even if you have no idea what the average baby weight is, if you know that was a z-score, you know it's a tiny, tiny baby. Do you see that? Okay. Let's suppose another infant had a z-score of 3.1. Now, what do you think? Any thoughts? Especially you medical people. And I know this from my brother. Any ideas? Okay, so we look at this 3.1. Now it's also an extreme outlier, but it's positive. So now instead of extremely underweight, now it's extremely overweight. So what that means, okay, is before it was born, they do all kinds of testing. They knew this baby was giant and they're going to do a C-section because that baby's not going to come out of the womb very easily. Does that make sense? And that's another big medical thing. That baby needs to be, C-sectioned out. Any questions on that idea? Okay, now we have a third infant. It was born with a z-score of negative 1.9. What can you say about that baby? Any thoughts? Yeah, what you would say is it's not exactly average, but it's really close to average, and it's only slightly below because negative 1.9 is very close to zero. Remember, -2 is an outlier. This isn't anywhere close to -2, right? This is really close to zero. So this is very close to average, slightly below, but you're going to treat this baby as an average kid, as an average baby, as a very typical baby. Does that make sense? And you're probably not going to have to do anything that is extraordinary, as long as nothing else going on with the baby. But in terms of by the way, you wouldn't have to worry about it. Does that make sense? So this kind of helps you understand z-scores. Okay, let me give you another fun example. Okay, my I got a I got a fifth 1,005. I got a 1,590 on my SAT when I took the SAT in math. Any guess on how I did based on that number? Is that good enough to tell you how I did? Okay, 1,590 when I took the SAT. And the good thing I know something about you, so I know what to answer. What I'm going to tell you, not what you're going to tell me. Okay, the answer is you probably have no idea. You weren't even born when I took the SAT. Okay, and the SAT has changed in the way it works for many years. By now, very few people even take it. In my day, you had to take it for college. That number tells you nothing. Does that make sense? You don't know if I did well. You don't know if I did terrible. You have no clue, right? And because you're not that old. You weren't around when that was happening. You don't know what SATs were like then. So now let me tell you my z-score, okay, was about 3.8 for my math SAT score. What does that tell you? Any thoughts? If my z-score was 3.8, what does that tell you about my score? My SAT score? Yeah, I was extraordinary high in math. Okay. Now for English, okay, we had to do math and English. My z-score for English was about 0.1. What does that tell you? Did I do terrible? No, I didn't do terrible. Did I do great? No. 0.1 is like really close to average. I was almost right on that average score. I wasn't special at all in my English. I was very special in math, which you probably aren't too surprised since I'm a math professor. But yeah, that's how I've always been. But with the z-score, you really can understand a lot more than with just the value. Does that make sense? So the z-score could be really useful in understanding the a specific value. Any questions on that? Okay, the secret word is sampling. Sampling. Okay, there's a lot of sampling done in statistics. So write that down and make sure you put that in your, this is going to be the week one, the webinar week one that isn't the orientation one. I forget what I called it, but you'll see, it'll be obvious. So the secret word is sampling. Y'all got it? Okay. I try to make it somewhat, obvious, except you would never just guess it if you didn't watch this webinar, right? So sampling. Okay. Any questions on that? Okay. Just another note, next week's webinar will be Monday at 6 p.m. Yesterday's was 6:15 for a really weird reason, and that was because I had a sub for I think I told you yesterday, but I had a sub for my colleague. I almost always have them at 6. So 6 o'clock is a very standard webinar time, and it'll be Monday. It's always going to either be a Monday or a Tuesday from now on, after today. This week I couldn't do Monday or Tuesday because we weren't going to happen. I mean, Monday and Tuesday we hadn't started yet. Um, and we have Mondays and Tuesdays. I never have it on a holiday. So there is I think there might be two Monday holidays, so that'll definitely be Tuesday. I try to make it I don't know if it's always every other week, Monday and versus Tuesday, but something like that. I try to not always have it on the same day so that people can make it, if you always have class or something on Monday, then you can make Tuesdays at least. So that's why I do some variation. I want to finish. We have a couple more minutes left, and the last thing I want to do is give you very important symbols for this class. Okay? This symbol right here, it has an X with a little bar on top. That represents the sample mean, and the way you read it is X bar. Okay? So the sample mean is the average of all of the people you asked or the data that you got, but not the average of the entire population. Okay? I want to give you a heads up warning. X with a bar on top is actually very hard to figure out how to type. So if you're doing, for example, the exam and you have to answer a question and you've got to put the word X bar in there, it's okay if you write XBAR. Got it? Because I don't want you to like really struggle on trying to figure out how to get this symbol in. Does that make sense? Okay. On projects, you should do the symbols because those are you get lots of help. You have weeks to do it. So that one, I can show you in a minute to show you how to do it. But when you're taking a test, wasting a minute could be bad. Okay. And you're not supposed to be asking people how to do things on the test. Not allowed to do that, by the way. Any questions on X bar? Okay, this one we talked about. This is mu, population mean. We're going to be using it all the time. It's the Greek letter. Okay. By the way, every system has a way to get Greek letters, but if you write mu, that's good enough. On the project, I want you to write the letter mu in Greek. Okay. Sample standard deviation. We use the letter S for that. That one you better know how to type the letter S. There's no alternate for that because that's S. Got it? So sample standard deviation is S. Population standard deviation, I mentioned already, that's sigma. And that one, again, on exam, if you type in SIGMA, I'll accept it. On the projects, you need to type in the letter because that you get lots of time and help. Any questions on sigma? Okay. If you have a proportion, that would be a yes/no survey question, and the proportion is the percent, kind of, you take the number of yeses divided by the number of total. That is, we use letter P for that. Okay. And that is the population proportion. I know this sounds a little weird because for mean for population, we use a Greek letter. For standard deviation, we use the Greek letter. The funny thing is, when I first taught this class, everyone used the Greek letter, and it was a disaster. Anyone know why? Any thoughts on why it was a disaster? This was 30 years ago or so. But it's not a disaster because it was 30 years ago. No one knows? Okay. I think the reason is you all know the Greek letter for P. What's the Greek letter for P? It's the one Greek letter everyone knows. Here's a hint. I'm going to be at a math conference for it on March 14th. No, it doesn't look like an N. The hint is I'm going to be at a math conference for this on March 14th. The Greek letter for P is pi. You all know pi. Okay, pi r squared. You've heard of that before. 3.14, March 14th, 314. So it was so confusing because we were using pi for population proportion and everyone's thinking that was 3.14. And it wasn't just us, the whole country changed. So now we use P for the population proportion. It's the only time you don't use a Greek letter actually for population. and when you're talking about a statistic. And for the sample proportion, we're going to use P, and it's going to have a little hat on top. And that one is also very hard to get on a computer. So P-H-A-T, P hat. Got it? Okay, so that's what we're going to be using in our class. And these are standard, by the way. This isn't just us. Any questions on the symbols? Okay. If there's no questions, it is 7:31, and I'm going to call it a webinar. I'm always happy to answer questions after. For example, if you want to ask questions but don't want to be public. So let me stop the recording.